Okay, hi. I think it's about time to start according to schedule. So welcome. Very glad for you to be here. It's very cool to have an audience. When you speak, it's cool. So I'm going to speak about this beast, Scala.js, which is new project, relatively new, 1 year and a half old now, and it's a JavaScript compiler from Scala to JavaScript. So what is it? It's super simple, actually. Scala.js is very easy to understand. It's basically a compiler from Scala to JavaScript, right? It doesn't do any fancy things. It's just a compiler. You learned yesterday morning that writing a compiler was super easy, So it was super easy to do, sort of. So it basically takes your Scala source code and translates that to JavaScript, and then that runs in your browser in Node.js, in Phantom.js, in basically anything that can run proper JavaScript. Yeah, so it's not much more than that. So First, we'll have a small look at what it looks like. What does it look like to program a little bit in Scala.js? So you know that with Scala now, if you want to try out some new cool technology, the easiest thing to do is to grab out an activator template and start using it. So we made that. We have this activator template here. So yeah, I'll refresh it so it doesn't look very, okay. Oh, it's great. So I can open this, and I will remove little things here. Great. So let's have a look at code here. Oh yeah, I have to go there. Main Scala, hello. I'm not sure I dare to make that bigger, because I will probably destroy the activator UI. But you can see it's basically a Scala source code. It has a top-level object, that's the entry point, a main method. There's some fancy thing with jQuery, more fancy thing with jQuery, even more, and then some Scala stuff here. So let's just look at what it looks like. So let's run this. So it's basically a simple hello world application with a clock that's just to showcase set timeout and this kind of things. And then a little postfix calculator, so I can multiply that by 5, and now I get 20, and I can divide that by 3, and I now get 6 because it's an integer calculator, so it rounds down to towards 0. So let's have some more look at the code to really see what's in there. So for the hello world part, it's very easy. I basically grab a reference to this box that contains my application, and I append basically a hello world text. That's super easy. So then the clock is, again, simply a paragraph that I add. But I have this tick method, and I want to use this set interval method, which is on the top-level scope of JavaScript. So I'm writing a Scala, but I can still use JavaScript APIs just like that. Just call them. They're there. And I can pass this anonymous function. It will be just treated as a JavaScript anonymous function. It will work. And so it calls it. And then that method uses the statically typed API to JavaScript, because setInterval was dynamically typed. If I misspell it, it won't complain, will just fail at runtime. But JS it knows that this is a statically typed thing, like I created. And then I can use all the Scala crazy stuff, like the string interpolation here, which uses the format interpolator with persons and whatever, to format the hour with the zeros and everything. And that's about it. I mean, afterwards, the formula, that's a lot of CSS because I have to cancel all the activator CSS stuff. And then we have this compute method, which is what you would expect in Scala code, right? You have everything. You have pattern matches, you have for comprehensions, you have lists, you have variables, you have conversions with two ints, etc., etc. And then I have this map of string operator to a function, and an anonymous function that performs actually the operator. Well, it's just all type checked. It's just Scala, basically. So that's it for the showcase of this little tiny thing. Let's go to the rest. So if you have missed the previous episodes, here is a little recap of what has happened over the last year. So a bit of history. First time I presented Scala.js was last year at Scala Days. People who were there will remember the big laugh when they saw, wow, that hello world is actually 16 megabytes worth of JavaScript. Yeah, it was. It's not anymore. We've made great progress about that. So in August, we introduced the Google Closure compiler. For those who don't know, it's basically a JavaScript to JavaScript compiler. It parses JavaScript, compiles it, and outputs JavaScript again. It's just smaller. But that brought it down to 900 kilobytes, which is quite an amazing reduction. Only it takes tens of seconds, minutes to compile, depending on your hardware. In December, I presented version 01. It was finally usable enough that I could call it 01. That was at a Scala Exchange. And by that time, we had actually a test suite, thanks to Jonas Fonseca. And in the more recent episodes, in February it was version 03, we brought it down to 300 kilobytes. In March, we introduced our own optimizer in addition to the Google Closure compiler, and that brought it down to 200 kilobytes. And with, in addition, this 1.5 megabyte that you can get with around 1 second, 2 second time of recompiling and reloading your application. And by now, just last Friday, we released 050, and we made it even smaller, and the compiler is even faster, so now the turnaround is less than a second, basically. So recap of all the features that we had so far. An SBT plugin, it just works with SBT, basically. You have incremental compilation, you have everything. IDE supports, you use Eclipse IDE, using the IntelliJ IDE, use it. It just works. You have dependency management, of course, because we're used to the good dependency management of SBT or Maven. Well, you have that for Scala.js as well. You can debug your code within the browser, stepping through your Scala code, because we made source maps. I won't expand too much on that today. And you can cross-compile codes for the JVM and for JavaScript, and on Scala 2.10 and Scala 2.11. So that was so far. So what's new in this version? That will be one big part of this talk. So the language changes. We've fixed the integer semantics. So you might probably know that on JavaScript you have only doubles, basically, which are called numbers. And so far, Scala.js just emitted all the numeric types of Scala as numbers. And so it would still run towards 0 if you divide it by an integer. But it would, if you add the two big integers, it would just fall out the range of a normal integer. And eventually, you would lose precision in the high numbers. Now with Scala.js 05, we really translate accurately the semantics that they're supposed to have on the JVM, so that you don't really need to think about, but how is this code going to behave on JavaScript? It is going to behave the same. There is still an exception with division by 0 is still an undefined behavior. We don't say too much about what's going to happen if you do that. We have also improved dramatically the interoperability with JavaScript. So it used to be that you needed to use explicit JavaScript types, JS number, JS boolean, if you wanted to interoperate with JavaScript APIs. There were implicit conversions, but still, if you pass that as a generic or as elements of arrays, the implicits don't kick in, and so it does not work as you expect. Now it all flows. Floats and doubles are just numbers. Byte, short, and int, they're just number, but with a restricted range. String is just a string, null, unit is undefined, and anything that's a subtype of JS any is basically itself, because that's a type that represents a JavaScript API. And then anything else, so any other Scala.js object, is basically opaque to JavaScript, except that you can mark certain members with the @JS export annotation, and that tells the compiler, please make sure that this is visible to JavaScript. This has a number of, it's useful for a number of reasons. So we've made also quite a few improvements to the generated code. For example, we don't box primitive types anymore. So in JavaScript, well, everything is dynamically typed anyway. So if you have an int and you put it in any, well, on the JVM you need to box it. Now we don't do that on Scala.js anymore. So that improves, of course, the speed of the program. We also improved quite the optimizer. So we have actually two optimizers. We have what we call the fast optimizer and then the full optimizer. Fast optimizer is for you to iteratively develop your program. So that's the optimizer you call every time you compile, because otherwise you have to feed these 20 megabytes of JavaScript to your browser, and it doesn't like that. It can cope with it, but it just takes 1-2 seconds just to reload your web page, and you don't want that. So we have this fast optimizer, which itself runs in about a quarter or half a second. But then it brings it sufficiently down that the browser can refresh immediately. So we spend more time optimizing, so the browser doesn't have to spend time parsing the JavaScript. And so that brings your code down to about 1.2, 1.5 megabytes, depending on your code base. And then when you want to produce the final code, use the full optimizer. This one takes a few seconds, 6, 7, 8, depending. And that uses the full capability of the Google Closure compiler. We've also better tooling. I'm just checking the time. Okay, great. I'm doing great. So better tooling is mostly through the SBT plugin, but we actually provide the meat of the tools, the actual work being done as a library, so you can use it in other build tools should you write a plugin for Maven, for example. I don't do it, but maybe some of you want to do that. Pull request welcome, by the way. So, and also other funny tools like Scholarjsfiddle, made by Howie. I'll show it in a moment. I can use this library to more easily use Scala.js in an indirect way, not just from the SBT console. So one big improvement we've made to the tooling is about the JavaScript interpreters that we can run from SBT. So you've probably heard of SBT Web, which has these things. We don't use it yet because we have some weird requirements. We tweak a little bit the JavaScript interpreters so they will feed back the output of the console in a way we can parse it and reproduce, for example, unit testing outputs in the classical SBT way. So we have a weird use case of JavaScript interpreters that's not well supported by SBT Web yet. So we have our own interface to that. But we can run Rhino by default, because Rhino was out of the box. You don't have to install anything, but it's kind of slow. although we have customized it so that it's faster for Scala.js, it's kind of a trick, a hack, but it's useful. Then the non-hacks are using Node.js and Phantom.js. So when you use the fast OPT stage run, which is basically use the fast optimizer, then run, this uses Node.js by default, but if you add the setting requires DOM, then it knows that your application actually requires some DOM to be, well, just to run, or to do your unit testing. If you're unit testing your DOM, you probably want to add that setting, and then we use Phantom.js instead. And of course, you can also use the full OPT stage if you want to run and test using the full optimizations, which is useful from time to time to make sure that the full optimizations don't destroy your code. And so that's what we recommend now for iterative development, is this tilde fast OPT stage test or tilde fast OPT JS to recreate a JavaScript to be run in a browser. Dependency management was also improved. So we already had dependency management for Scala.js libraries, because for that we just use jars in the same way that we do for Scala code or Java code, for that matter. But for JavaScript libraries, I'm going ahead of myself. I'll do the other one after. So for JavaScript libraries, we have this problem that is, well, we looked at how do JavaScript developers do their dependency management. It seems they don't. So we had to come up with something. So we made these extensions to the library dependencies of SBT. We call it JS dependencies, and there you put a WebJar module ID, and you basically add slash and a number, the name of a file name contained somewhere in that jar to be added to your running environment to run your JavaScript. So if your Scala.js unit testing code requires jQuery to be there, just add this and it will be there and you will be able to use it. This also works transitively. So actually, if you depend on the typed interface to jQuery that we provide, this one depends on this jQuery file in that WebJar, so you don't even have to specify it yourself because transitively it will be added. You can also tell SBT to actually generate a concatenation of all the JavaScript files you need to be output in one JavaScript file. You can just put in one script tag in your HTML page, and then you don't need to worry about adding the script tags for all the individual JavaScript libraries as well. So back to slide 18. Backward binary compatibility. You know that binary compatibility is a hot topic in Scala. We always have these troubles with binary compatibility. So we made it pretty serious from the start to think about what does binary compatibility mean for Scala.js. And it basically means, it's the same as Scala, basically. It means if I have compiled some library with Scala.js 0.5.0, with what other versions of Scala.js can I use that library? And the answer we provide is anything that's after 0.5.0 in the 0.5 series. So the binary suffix for Scala.js is sjs 0.5. And then you're also binary dependent on the way the Scala compiler does things. So you're also dependent on the binary suffix for Scala. So if you publish an artifact for Scala.js, the SBT plugin will automatically add that suffix, which is underscore sjs 0.5 underscore .2.11. And if you want to depend on the Scala.js library, well, you just use the triple $sign instead of the double $sign to add the two suffixes so that you can resolve the library that was built for your version of Scala.js. And so that's an example for depending on the DOM, on the static types for the DOM that we provide as well. That's it. We also improved documentation. used to be scarce. Now we have a full-fledged tutorial which will get you step by step into building your SBT project from scratch so that you understand what's all in there. And it will explain you what all these things means and how you actually can start programming in Scala.js, start using the DOM, statically typed DOM API, using unit testing facilities, and so on. So I think that's all about what's new. Now I want to. That was the part. Okay, we've made some good progress now, and we're very good of how the language works now, because it's kind of a dialect of Scala, if you want. So it's kind of a slightly different language, but now we're really confident about the semantics of that language. Now I want to show that people are actually using this stuff, and they built quite awesome libraries and projects with this. So first, and probably one of the big stuff that was already presented some time ago is Howie, who made this Scholarjsfiddle, which is basically a web interactive environment that gets you started with Scala.js. So this is the front page, but I go through this tiny example. And you have your editor on the left, and you have a canvas on the right you can just use. So you can just use this canvas, which is provided to you in the environment. And if I change this red to yellow, because I prefer yellow, and Control Enter, it will send that to a server that compiles it, sends back the JavaScript code, and it runs it. So that's very cool to prototype things in the browser just to get a feel of Scala.js without even having to set up an SBT project or whatever. You can just start using it. It's very, very cool. Another library of Hai's. He made a lot of them, but that's the only two I'll show. So this is Microtest. It's basically the best testing framework we have for Scala.js now. And it's actually a cross-compiling testing framework. So it works with Scala JVM and Scala.js on 2.10 and 2.11. So you can write your unit tests so that they themselves cross-compile on the JVM and on JavaScript and make sure that your cross-compiling library actually works on both the targets and on both Scala versions. It's quite amazing. So when I wrote the abstract of this talk, which was already 5 months ago, the thing I was excited about was this port of Akka actors to Scala.js, which I made in some time. Lots of copy pasting, lots of fiddling with the internals. And so it's very much in the proof of concept state, and it's not the most exciting thing anymore. There are more exciting things, but since I promised I would show that, I don't want to. So yeah, this is the right one. So I want to start SBT again here. And yeah, so just opening that and run. So now my web application should be up. And I directly go to the full optimized version because it's going to run a little bit faster once Play has decided that it's time to compile. Yeah, great. So my username is typically sjrd. That's how I'm known on GitHub. Connecting, I'll create a room, and I also, well, connect another person, otherwise it's not very useful. So let's say my coworker, colleague working also on Scala.js is here. I don't know his Gravata email, so let's leave it. And I can join my room here and send messages, and I will receive them, etc. And should I leave suddenly, well, it will tell, oh, okay, SJ left the room because. So this is all actors. This is all Akka, basically. It's the Akka feel. I mean, it's actors. it's even the same syntax, the same API. The internals have changed, but basically the Akka actor package, you basically use it, and you can watch actors. You can communicate between Akka on the client and Akka on the server just by sharing actor refs, and you can send messages, and it all works. And should an actor ref reach another client, that client can send you messages through that actor ref, and it all works transparently. The message still goes physically through the server, but it goes back to the client afterwards. But it's still very much prototype-ish. So it's a proof of concept. Now Typesafe is looking into making that a little bit more robust and maintainable also with the original Akka code base. So if you were wondering how much of the Scala language do we support, well, we basically support all of it. And there is not a single thing in the Scala language that we don't support. The compiler, it's complete. It compiles any Scala source code. And to prove that, I'll show you that we can actually compile and run shapeless and parboiled, which depends on shapeless. So a parboiled example is here. It's been compiled by Scala.js, and before that, shapeless has been compiled. And this is a basic ABC parser, which will tell you, okay, this one is valid, but if I put an additional C here, oh no, here I have an invalid input, I shouldn't have a C there. So there is a little bit more you don't see that actually. Sorry about that. Yeah, so there it is. So this one is valid, this one is not. And here is a more complete example with an actual calculator. This one, it's infix. It's a little bit more difficult to parse that postfix separators. And if I add a syntax error, it will tell me, etc., etc. So this is basically parboiled, running, depending on shapeless, all compiled to JavaScript with Scala.js, and it all works. So then, what else do we do? So yeah, forgot to mention. So this port has been done by Alexander Mills. Sorry, if you're there. Sorry. Scala.js React is another fun library. It was done by @Kanterov, and it's basically a tiny Scala-esque wrapper on Facebook's React.js library. So React, if you don't know, is a UI library that works with an immutable shadow DOM, and you have widgets that generate a shadow DOM version of what they should look like, and then React diffs successive versions of the DOM to produce the minimal set of change it has to actually perform to the DOM, to the actual DOM API, because they found that the bottleneck in most DOM-heavy applications is actually just mutating the DOM. So let's have a look at that one. Is this one? Yeah, it's that one. I can probably. Yeah. So basic hello world here. No, I can't. Okay. Basic hello world. That's not very fancy. There's a timer. Well, time's out. Say is a basic say application, nothing fancy. But what's cool is this famous to-do MVC here. So that's all done with the React API. So prepare my slides for Scala Days. But this one is done. So that's cool. And I can remove the completed items. Well, if you've attended the talks by Harry yesterday on what's the I don't remember. Scala RX. Thanks. I couldn't remember. So this is the same application, but this time it's written with this Scala.js React bridge, statically typed bridge to the Facebook React library. And what else do I have? Yeah, Scholarjs binding is the other side of UI frameworks and libraries for Scala.js. So you have guys who try to wrap an existing JavaScript UI framework, and then others who create their own library entirely in Scala.js. So Scala.js binding is one of them. As far as I can tell, it's Angular-like in the sense of the data binding works similarly to Angular. And that one I have actually to launch a web server for that. Do I have I killed this one? No, maybe killed this one. Exit SBT, not free memory. Run. So where is it? Probably yeah. 5. This one I'll show full screen. So oh, it's not yet refreshed. So let me wait. Yeah. So this is a play web server with a Scala.js client side, all written with Scala.js binding. That's the demo website of Scala.js binding library. And it basically showcases a few widgets. So you have this, which is a randomly changing thing. But more interesting is this text. I change it, and the other widgets that are bound to this data are automatically updated in all direction. It shows how it works. It's not much code. Basically, the Scala.js code is over here. It's only a little bit of things. This one uses quite heavily macros to work, including macro annotations if you really want to. Oh no, sorry, that's Facebook, the React API that provides you with transforms the XML literals of JavaScript to creating the shadow DOM of Scala.js React. This one is pure Scala.js, and it uses macros to make the bindings. So yeah, macros work as well. But you probably figured from the fact that Shapeless works. And the last library I want to talk about is Carlo. That's a very fun one because it's not a Scala.js library. What it never was. It's a Scala library. But the guy who did that, Elia Lakin in GitHub, wanted to make a web demo of his library because it's such an awesome library. So how do you make a web demo of a Scala library? Well, you're stuck, right? Well, not anymore, because he actually ported his library to Scala.js just to be able to use it from a JavaScript UI. So this is kind of fun because it's the only UI so far that I know of that is basically written all in JavaScript, the UI, but it just calls into the Scala.js compiled library that was originally written for Scala. So this is it probably, you probably won't see the code, but this is basically an incremental parsing library. So the point of it being incremental is if I add lots of nodes here, I'm trying to saturate a little bit. You know, you see it takes time reparsing every time. But because I've added lots of things at the same time. But if I now change a little thing here, it can reparse the whole thing. Well, that's the point. It doesn't reparse the whole thing. It only reparses the things that are changed. And I can alter the structure as well. So I can remove this, and then I have a compiled error, but that's fine. It doesn't crash. And now I can remove the thing altogether, and then it adapts, and it doesn't have to recompile to reparse everything. It's kind of impressive. And this is all written in Scala, the library, not the UI. The UI is written in JavaScript. So there are lots of other cool stuff, but I don't really have the time to present everything. So I will finish by answer this question, which I'm typically asked quite a few times: how stable it is. I mean, can I use it now? Does it really work? Well, to convince you that it really works, first, the official answer is still an experimental thing, still an O.X version, so we don't guarantee anything. Things could change, things could break. But at the same time, we have a test suite which covers everything that is Scala.js specific and then some more. There's 405 unit tests. We run that for every pull request with Rhino, Node.js, and Phantom.js, with Scala 2.10, 2.3.4, and Scala 2.11, 0, and 1, with the experimental flag, which changes things in Scala.js because of some single abstract methods, and without the flag. We run that in the fast OPT stage mode and the full OPT stage mode, and the third mode, which is legacy. Oh, I shouldn't say that. Well, old stuff we don't want you to use anymore. It's the slow one. And this also type checks our entire intermediate representation after having compiled it, so we can make sure that we haven't done anything wrong. And then we also compile the Scala test suite itself, at least parts of it. So currently we cover 822 tests, which amounts for a little more than 50%. The other 49% are not things that it's not language construct we don't support. It's mostly JVM specific things like concurrency, the parallel collections, all kinds of stuff really related to the JVM that we don't support. Runtime reflection as well. And that also we run on a nightly basis with Rhino and Node.js and with the two versions of 2.11. So what's missing? Well, as I said, the compiler itself, it's okay. It's full, it's complete, it's probably pretty much bug-free. What is missing is mostly parts of the Java standard library, because Scala.js doesn't compile Java to Scala.js. It doesn't compile bytecode to JavaScript. It compiles Scala source code to JavaScript. So if you use Java library, well, then you're really stuck. But what about the parts of the Java standard library that the Scala standard library itself uses, or that are so important that we need them? Well, for these, we basically rewrite them in Scala.js itself, so that they will work. So for example, the regular expressions library is rewritten. Something that's missing also is official support and published artifacts for the important libraries in the Scala ecosystem. So Shapeless and Parbold, for example, they work, but if you have to clone the repo and publish local it, and so at some point we would like to at least have people maintaining the official ports to Scala.js of these important libraries. And also, what we would like is more static types for other libraries. So the two that really work well is DOM and jQuery, but there are lots of other JavaScript libraries, and we're missing the static types for them. But the cool part is, all of it, you can help. It's not hardcore stuff. It's not compiler stuff. It's really easy work. So if you need Scala.js, if you want it, and you need some JavaScript library, and there's not the types are not yet there, well, make them and then contribute to the community. So you can help with all of these things. And lastly, and with what's coming. So I'm working on an even better optimizer, an incremental optimizer, which will do inlining to speed up the program, because right now we have reached a reasonable size of the code, but we're not quite there yet in terms of execution speeds. So to give you figures, we're basically between 3 and 10 times as slow as handwritten JavaScript. Depends on what you use from the standard library. But I think that's mostly because of lots of interactions in the Scala standard library that gets inlined away by the JVM, but not so much by JavaScript VM. So we want to inline that at compile time. Then Tobias intends to work on compiling the compiler so that we can run the compiler in the browser. We're not yet sure it will work completely, but we're hoping we can do that now that we really have full support for the full language. And as I mentioned, Typesafe is working on a non-prototype port of Akka actors, but that's also kind of a far-fetched goal. So I think that's it, and I'll be happy to take questions, of course. Yep.
You told quite a lot about libraries, but nevertheless, I did not fully understand. Did you translate all Scala libraries to JavaScript, or do you ignore them and the user will be based only on JavaScript libraries?
The question is, we've talked about libraries, and I take it the Scala Standard Library, for example, or other libraries. Do we have to, well, did we recompile them with Scholarjsfiddle, or do we have to rely on only JavaScript libraries? Well, the answer is you have both. So if a library is written in Scala, for example, the Scala Standard Library, it compiles to JavaScript using Scala.js, and then you can use it just like that. That's how we use Shapeless. We just compile it, and you can just use it. For JavaScript libraries, you can just use them through the dynamically typed API or the statically typed API. What you cannot use is Java libraries or Scala libraries that you only have in binary form, because that's too late. We need the source code. Yeah.
You mentioned us at some places, so what does that mean, and what is the opinion of Typesafe on all this wonderful work?
I didn't get the first few words of the question.
The background supporting organization and the relationship to Typesafe.
Okay. The question is mostly about the relationship with Timesafe and how this task force that is assigned to this. So until recently, there was only we were only two guys officially working on it at EPFL in the Scala team, Tobias and me. And there are a few community contributors, first of them Harry. And but only recently we've started talking to Timesafe about making this well supported, and so now they have assigned I think one person really on this Akka thing, but we want to make this more into a product and production ready, really. Yes, so we're actively talking with Timesafe and how we can get this to work. Yeah. Yes. There. Mm-hmm. Okay, so the question is about the TypeScript, the TypeScript definitions for static types for JavaScript libraries. And yes, there was and there still is a project that automatically translates type definitions written for TypeScript to type definitions for Scala.js. That still works. I mean, we haven't made much of noise about it because it won't go much farther than it is. It parses all of TypeScript and emits Scala.js code. So, but it doesn't do a perfect job because it only does a very shallow transformation. It parses source code and emits source code back, but it doesn't try to actually compile the TypeScript. So sometimes you have to rewrite a little bit some parts of the emitted Scala.js code. But basically, yes, you can use it. So, and that helps to create at least the initial version of type definitions for for Scala.js just by importing the existing TypeScript ones. Yeah. Yeah. So the question is about Nashorn, and have we tried to run Scala.js with Nashorn? We've not tried yet, basically because whatever is the answer, we can't yet drop support for JVM 6 and 7. So it hasn't been a priority to test this, but eventually we will test it and probably optionally provide running with Nashorn. Yeah. Yeah.
So there's a number of issues with Scala due to type erasure.
Yeah.
And these generally stem from deficiencies of JVM.
Mm-hmm.
How does Scala.js compare to Scala in that sense? Because if, potentially, I mean, there's maybe an opportunity to build a better VM, or is it just as bad?
So the question is about all the problems, well, some of the problems you have in Scala because of type erasure, and how does Scala.js work with these, and does it do better? Is it possible to do better? Actually, we try very hard to be as bad as the Scala on the JVM, in the sense that we want your code to cross-compile and run the same way on both. So if we fixed things on Scala to JavaScript, we would prevent you basically from having code that cross-compiles, and that's not a thing we want to do. So we try to stick to the Scala semantics as much as possible, and yeah. Yeah.
So then a follow-up question. So in one of the talks, I forgot who that was, but there was a talk on potentially compiling on a better Java VM.
Avian, yeah.
Avian, right? Yeah, so that would potentially fix some of the deficiencies, right? Maybe you have to set compile flags or whatever. So when that happens, what would the relationship be to Scala.js?
So the question is, should we target Avian more than the original JVM in order to be able to fix some of these things? What would be the relation to Scala.js? Well, Scala.js will probably always try to stick to the semantics of whatever is the official mainstream semantics of Scala. So if Scala moves to Avian and changes semantics because of this, we'll try to align with this. Yeah, but basically our main goal is we want you to be able to cross-compile your code. So we want to make sure that that works as best as possible. Yep. The question is about tail calls, because tail calls are now specified in ECMAScript 6, which is now implemented in the most recent versions of the browsers. Do we plan to support them in any way? Yes and no. We will still keep the tail calls transformation that is performed by the Scala compiler, because for this one we have a compile time guarantee. If you put the @tailrec annotation, you know that this is tail call eliminated, and that is important to some things. But at the same time, we try very hard to produce JavaScript code that preserves the tail call, the tail call, but not only the tail recursive call nature of your calls. So if you write something that is a tail call, but not a tail recursive call in Scala.js, it will be translated to a tail call in JavaScript, and it will benefit from tail call elimination from the runtime in that case. Yes. Okay, I think that's it. Thank you again.